Hello, stargazers, and welcome to the sky this month for March 2021. My name is Joe Grida. I'm the Technical Information Officer for the Astronomical Society of South Australia, and I'm going to go through and show you some of the things that you can go out and see during the month of March. So let's draw the curtains as we usually do and have a look at the all-sky map. Let's zoom in a little bit so we've got a better view. And as always, we'll start with the west because that's where the stars set first. You can see here that the summer constellations of Orion, Eridanus, Canis Major, Taurus over here with the Pleiades are all starting to set quite early. Don't forget, autumn is in March, so our autumn stars are starting to make their presence felt in our evening sky, and we'll come to those in just a second. But as I said, here's our summer stars slowly starting to sink into the western sky, even over in the south. Constellations like Tucana, the toucan, and Pavo, the peacock, Ara, the altar, are all quite low in the southern sky. But you know that summer is well gone, and autumn is coming when the Southern Cross and the pointers are getting fairly high up in the southeastern sky early in the evening, and as we move over further to the east, Libra, the scales, is already rising. It only seems like yesterday to me that we lost Libra and Scorpius, the scorpion, at the end of winter, and here they are already coming up for us. So it's going to be chilly nights from now on, guys. So when you go out observing, just make sure that you wear a good warm beanie and a good warm coat. Further over in the east, the autumn constellations of Hydra, Leo the Lion. We'll spend a bit of time with Leo the Lion tonight. Virgo is rising as its main star speaker. With Corvus, we've got the Sombrero Galaxy here, which we'll talk about. We'll wait till it gets a little bit higher up in the sky. So I might feature the Sombrero next month for you, along with Corvus the Crow over here. As we head to the northeast, Cancer, constellation of Crab. Cancer, the crab, is now crossing the meridian, so that'll be heading towards the west very soon into late March, and of course Gemini with the twins of Castor and Pollux over there. High up in the sky, Canis Major with Sirius is still quite high. There's quite a number of open clusters in this part of the Milky Way. M46 and M47 in Puppis are magnificent star clusters to look at through a small telescope, even a pair of binoculars. You can see that quite well. As we head towards the south, following the Milky Way, you'll see as we head overhead, we've got bright Canopus over here. And then into the heart of the Milky Way over here, the Eta Carina Nebula, the famous Eta Carina Nebula, which again will feature in another month or so when it gets even higher up in the sky for you to have a look at. Let's move on. The moon phases for March. Last quarter is on the 6th. A new on the 13th, first quarter on the 21st, and full on the 29th, which means that from the last quarter until the 19th of March, when we get to a tiny waxing crescent. We got nice dark skies from the 6th of March right through to the 19th during the evening. So this is your chance to get out there with a telescope and start looking for some faint fuzzies. After that, from the 20th onwards, you've got a moon getting progressively brighter, and this is your chance to be looking at the craters and mountains on the moon, which we'll get to in just a second. Right, lunar feature of the month. This month is Fra Mauro crater. As you can see on the full moon photo here, it's best visible just after a first quarter. The moon grows in size from new along here from east to west. So when it gets to first quarter, it's bisected right through the middle. So a day or two after first quarter is the best time to have a look at this area here. Here's a larger photo of just that small area just there on the northern end of Mare Nubium, the sea of clouds, and here we see it just in there. As I said earlier, it's best observed a couple of days after first quarter, or you could look at it the other way, just after or just before, no, just after last quarter. So you've got the 6th of March in a few days' time, in about a week's time, or you can have a look at it 2 days after first quarter, around about the 23rd of March. And this is the aspect that you'll see if you look at it on the 23rd of March. Okay, Fra Mauro is the large walled plain that you see here, right in the middle of the photograph. During the late heavy bombardment area on the moon, when everything got pretty hot, there was a lot of lava flowing to the surface, and it flooded some of these craters and plains. You can see here that the lava didn't quite get all the way up this walled plain, because it's still rough on the edges here, whereas it's nice and smooth just in here. This is where the lava would have broken through there. Fra Mauro is 97 kilometers in diameter, so this gives you an idea of the scale on this photo, and it's named after a Venetian geographer who prepared a map of the world in 1457. This is also the landing site of Apollo 14, just slightly north of Fra Mauro, in these sort of hilly areas here. And this is where astronaut Alan Shepard is famous for having hit a couple of golf balls on the moon. Still the only person that's ever played golf on the moon. Here's a panorama taken out of the Antares lunar lander. Nice panorama. It shows where the astronauts had been. Don't forget that Apollo 14 did not have a lunar rover, so they actually carried a little hand cart, like a shopping cart, around with them, and these are the wheel marks from that hand cart. He hit 2 golf balls, and considering that the gravity on the moon is quite low, he didn't get to throw them very far at all. They only went 22 and 36 meters. But don't forget, he's doing it with a spacesuit where he can't use 2 hands. He's only got to use 1 hand on his golf club, and hasn't got very much movement at all. So I'm even amazed that he actually even got to hit the balls at all. Somebody calculated that a golfing pro, with all the movement that he requires, could hit a ball at 298 kilometers an hour, and on the moon that would travel around 4.2 kilometers. I remember some time ago somebody asked me, when we're talking about the golf balls, somebody asked me, could a golfer actually hit the ball for it to leave the moon's gravity? And that's never going to happen. I don't think there's even a golfer on the planet that could hit a ball at 8,496 kilometers per hour. Especially not the golfer that just had the accident. I've forgotten his name now. Mental blank. Okay, other features around here, the crater Parry here. You can see where, again, the lava flooded the floor. This is named after Sir William Parry, an admiral in the British Navy and an Arctic explorer. Bompland, the remains of another walled plain, 60 kilometers in diameter, named after a French botanist. Now, if you look carefully along the floor of these walled plains and craters, you can see all of these cracks in the lunar surface. Try and see those with a telescope when you actually get a chance to look at this area. And there's a couple more. There's a Gueric plain here, another wall plain that the lava burst through and flooded it, and then another little meteor crashed on the surface of that and created another crater. And the last two, Talansky over here and Kunt over here, two smaller craters, 11 and 13 kilometers in diameter, both named after 18th century physicists. So a nice little area for you to explore with your telescope. All right, moving away from the moon, let's have a look and see what the planets are doing during March. I always create these diagrams for the middle of March, and you can see why Venus is invisible to us at the moment. It's right across to the other side of the sun from us. We won't see Venus into the evening sky until about late April, when we'll see it low in the west, and it becomes the evening star for us. At that time, on the 15th of March, it's 1.7 AU. Now, 1 AU is 150 million kilometers, so Venus must be around about 220 or so million kilometers away from us on the other side of the sun. Mars is still visible in our evening sky, getting lower and lower as we keep leaving it behind. Mercury is visible this month in the morning sky, and we'll come to him in just a second. As we look the other way towards the outer solar system, Jupiter, Saturn, and Pluto are now starting to come out from behind the sun in the early morning. And again, we'll talk about Jupiter in just a second. As the Earth moves around the sun in this direction, obviously, as we look out towards the outer solar system, we'll be looking out that way, and Uranus is heading right behind the sun from us, so no chance of seeing Uranus in our telescopes at the moment, and the same thing for Neptune. So we won't be seeing them until later in the year. Okay, coming up very soon. I mentioned Jupiter and Mercury. Well, you can catch both of them in the field of view of your binoculars or a low power telescope at the same time on the morning of the 5th of March. As you look at them, Jupiter obviously will be the brighter of the two. and Mercury just to its left. They're only separated by 21 arc minutes, and that's only 2/3 the diameter of a full moon. That's why I say that you'll have no trouble seeing both of them in the field of view of your low power telescope or a pair of binoculars. And I actually made a discovery whilst I was looking this pairing up, that in the same field of view, if you position it just right, you'll have Mercury, you'll have Jupiter, and you'll be able to see its 4 Galilean moons. But in the bottom left-hand corner, you've actually got a comet there as well. Now, I don't know how easy you're going to be able to see that because it's 10th magnitude. It's quite low in the sky, so you may not be able to pick it up. You definitely won't see it in binoculars, but certainly give it a go in a telescope. You may just be able to pick that up. Of course, here's a challenge for all of you imagers. Get out there and see if you can capture all 3 of those objects in your image. A little bit about Comet 10P Tempel. On that morning, it's 213 million kilometers from the sun and 335 million kilometers from Earth. So it's on the other side of the sun from us. The core of the comet is thought to be around about 10 kilometers, but because the sun is heating up the ice and gases on the comet, all that gas and dust is evaporating and hanging around the core of the comet, causing what we call a coma or a big head. And that big head is 429,000 kilometers in diameter. So that is absolutely huge. It has a 5-year orbit, so it comes back every 5 years. We can see it again in 2026. It was discovered in July of 1873, and it actually comes closest to the sun on the 24th of March. So have a go, see if you can find it. It was a surprise to me. I had no idea that the comet was there until I fired up Stellarium and it showed it to me. 5 days later, you can see here that Jupiter and Mercury have actually separated. Jupiter is getting higher in the sky. Mercury, because it's closer to the sun than we are, it's now moving back down towards the horizon, and it'll come back as an evening object in April for us. But yeah, you have a string of planets: Mercury, Jupiter, a little bit higher, Saturn, and then the Moon a little bit higher and to the right of Saturn. So that should be a nice view in the morning, just before the break of morning twilight. I'm sure everybody has heard of the asteroids, and everybody knows about the asteroid belt, which sits between the orbits of Mars and Jupiter. And there are millions of tiny objects that orbit along that area. And I'm sure you've heard of names like Ceres, Vesta, Pallas, and so on. Vesta is one of the brighter ones, one that you can actually see with a pair of binoculars, if you know exactly where to look. Vesta is the 4th asteroid discovered and the 2nd largest, with a diameter of 525 kilometers, discovered by German astronomer Olbers, after whom Olbers paradox is named, and we'll talk about Olbers paradox on another show. He discovered this on the 29th of March, 1807, and is named after Vesta, the goddess of the home from Roman mythology. Here's a comparison of the size of Vesta against some of the better known objects in our solar system: Mars, Mercury, Earth's moon, Ceres, which is the largest of the asteroids, and then there's Vesta. So comparing it to the moon, you can see how much smaller Vesta is. There's a close-up shot from a spacecraft that visited Vesta. Here's the 4 largest asteroids. As I said earlier, Vesta is the second largest at 525 kilometers. Ceres at 939. You can see that it is actually quite spherical. Even Pallas and Hygeia are showing signs of being spherical. All right. So when I said earlier that Vesta was reaching opposition, it reaches its closest point to us, and this is its path around the hindquarters of Leo the Lion, from February right through until June. We might have another go at looking for it in June when it comes close to M65 and M66 over here. But for this time round, I'd suggest that we have a look at it on the 17th of March at around about 11 p.m. Because it's going to be very, very close to a similar brightness star called Hipparchos 54319, right in the hind quarter of Leo the Lion. There's a close-up picture. This field is the size of a full moon. So if we have Vesta in the middle of the picture, there's the star Hipparchos 54319. You can see them both here. So it should be really simple for you to be able to locate it. They're both just over 6 magnitude, so binoculars should do the job for you quite well. In binoculars, they'll look even closer. This is a view the size of a full moon. So in a low power telescope, around 60, 70 times, you should be able to see that quite easily. Right. I didn't include a double star of the month last month, so I thought I'd use Gamma Velorium high in the southern sky for this month's. This time it's not a double; it's actually a multiple star. Gamma Velorium is the brightest star in the constellation of Vela, the Sails, and it's relatively bright at magnitude 1.7. It's composed of at least 6 stars, 336 light years from Earth. Let's go through each of the component stars. You can split this up quite easily in a small telescope. No problem at all. The brightest is Gamma Velorium A, just labelled here. It's a spectroscopic binary, which means that we can't split that star into its 2 components because they are just so close together that even a large telescope cannot show it. We actually have to split the star's light with a spectroscope, and then it shows us the 2 spectral lines from the 2 stars. The main star is a blue supergiant, and the companion is a massive Wolf-Rayet star, quite an unstable, very hot, massive star, which is losing a lot of mass, and one day will blow up as a supernova. And when it does, it is at the moment the nearest supernova candidate to Earth at only 336 light years away. You may have heard us talk about the star Betelgeuse in Orion, which is believed to be on a path towards explosion sometime in the future, but that's over double the distance that Gamma Velorium A is. Gamma Velorium B is a blue-white star. Again, very easy to see through your telescope. C is a white star of magnitude 8.5. That's probably where you'll stop with a small telescope. You may not see the D star, which is at magnitude 9.4, and its companion is 13th magnitude. So definitely not visible in a small telescope. So where is this gem of the southern sky for you to have a look at? Oh, a little bit of trivia. If you are living on Neptune, then Gamma Velorium is the southern pole star for Neptune. You'll never be able to prove me wrong. Right, here we go. Looking south, you can see the Southern Cross just over here. There's the Alpha and Beta Centauri, the two pointers. As we follow our way up the Milky Way, we go past the Eta Carina Nebula just over here, and we come to the star called Rigor. Rigor is the proper name for Gamma Velorium. Let's just zoom in on that area and give you an easier way to find it. Although, as I said, being bright, it shouldn't be that difficult to find. Don't know how many of you have heard of the False Cross. These four stars here make a much larger version of the Southern Cross called the False Cross. So if you use Avior over here, go to the second brightest star in the sky, Canopus, to your right when you're looking up, and Rigor makes little sort of out of shape a triangle with Avior and Canopus. Not that difficult to find at all. All right, I love autumn and winter because, as Elmer Fudd here says, be very, very quiet. I'm going to be hunting, but I'm not going to hunt rabbits. I like to go hunting galaxies, and I just love galaxy groups like this one, the Able Galaxy Cluster 1367 in Leo. It's 330 million light years away, and it's part of a filament of galaxies. They go all the way out to the constellation Coma Berenices. Also part of the Able 1656 in Leo, and lots of other smaller galaxy groups. But think of this one as its own cluster, Galaxy Cluster 1367 in Leo. This is a view that's 30 arc minutes wide. So again, around about 60, 70 times in your telescope. Now, these galaxies are relatively faint, so you are going to need a reasonably large telescope. Anything above 10 inches in diameter or 250 millimeters will do it in a dark sky. This is centered on the brightest galaxy in the group, which is this one here, NGC 3482. Oh, I should have reminded, or that reminds me, that a lot of the galaxies in this cluster are spirals, and we know that spirals are in the early evolution of a galaxy. So this tells us that this galaxy group must be relatively young. As I said, the brightest galaxy is 3842, which is this one here. 3862 is actually out of the field just up here somewhere. Discovered by William Herschel, the same man that discovered the planet Uranus, and his son John then added a lot more galaxies to the cluster. I'm not sure that William would have seen all of the fainter ones with the telescopes that he was using. The NGC catalogue lists 26 galaxies in this area, just in the NGC catalogue, and there are other catalogues like the IC and the PGC catalogue that go even fainter. But you need larger and larger telescopes to be able to see those. Okay, so where are we going to be able to find it? As I said, it's a great target for moderate to large telescopes, and most of the galaxies are contained in that 30 arc minute field of view that you can see there on the right. All right, so where are we going to find it? Well, we had a look at Vesta before, just in the hindquarters of Leo the Lion. Well, the galaxy cluster is just a little bit below the middle of the tail of the lion, just inside that little square, blue square there. Let's zoom in on that, and we can see as a large area here, the little 30-minute field of view that I showed you before is just this one here, just in there. So you can see how much further that galaxy cluster actually goes. It's quite a large field. Really nice to just work your way around there and just count. See how many galaxies you can get in the one field of view. And I always like to remind you that all the sky images that I create are done with Stellarium software, free software that you can download. Go to stellarium.org and download the version that suits your particular device. Highly recommended. And that is a thank you for watching. That's your lot for this month. I hope and encourage you to get out there and do some viewing. Get out there in the morning sky. Have a look at Jupiter and Mercury close together. Get out in the evening sky and have a look at Gamma Velorium. Have a look at the Leo cluster of galaxies. If you got any questions, I always welcome your emails. technical@assa.org.au, and you can also get the latest information about ASSA activities on our website, or subscribe to our YouTube channel where you can watch a replay of this and many other Astronomical Society presentations. And you can also follow us on Facebook for any last-minute events and announcements for you. So thank you very much. Have a great evening and have a great month of observing.